Hey everyone, today we'll be doing another Leetcode problem 145 binary tree post order traversal. This is an easy problem given the root of the binary tree return the post order traversal of its node values. So what is a post order traversal? A post order traversal is a traversal in which we go left first then right and after that we go to the parent or the root node you can say. For example, in this case, we have 1 as a root, so we'll go to the left first. We do not have a left, so we'll go to the right, and after seeing this right we will say that if this node has its own left or right. Yes, it does has have its own left, so we will just go 3 to 1, like in the reverse order, like node, leaf node, then parent, then it's on its parent. So 3 to 1, like you can see here in the output. So that's it, we'll just implementing it. This is an easy problem. So first, our base case, if there is no root to begin with, like the other algorithm problems so we have solved so far, we always handle this case and we'll be making a stack in which we'll be appending our root. And now we will make a list, empty list. Oh, okay, now if there is something in the stack, we will say if there is something in the stack, this whole loop will continue. We'll be making a temp variable in which we will take the value at the top of the stack, the value at the very top, and append it to, not appending but inserting, in this case inserting at 0th position, and temp dot val. Yeah, this is it. And now we have a condition, if that specific node has its own left first and then we will go to the right. So if temp dot left is a thing, if the temp variable has its own left, in Python this is how you will write it. So what we will do is just appending to the stack, appending temp dot left, and also we will check if that specific temp has its own right. We will append the right also to the stack, right. Okay, so after doing all of this we will just return um, result, and this should work fine. I'm sult. Okay, this is good. So let me see if it works, then I will explain how things are. Result, yes, I made a spelling mistake like always. Okay, this works fine. Let me submit it. Okay, this works. So what is happening here is we have our root in our stack. We will be using it in our temp and inserting it at the 0th position. When in the next iteration we will when we will see that it does have its own left and right. For example, what if we have a binary tree like 2, 3, and now let me see, say if there is a 4 and there is a 5 and there is a 5 here also, like 7 I will say, and a 6. Okay, so I think you understand how they are like in pattern. So first of all we have root, this will be our stack, we will append root to the stack. Okay, now, and this will be our resultant, this is our stack, this is our result. Okay, so first of all we have our root in our stack, which is 1. We will pop it and append at the 0th location. 0th location is 1 in the result. Okay, now we will check if this specific temporary variable has its own left and right, and if it does we will append it to the stack. So there is no 1 anymore, because we just popped it. So the left is going first, like 2 is going first and then 3 is going. So the next iteration will continue and we will just pop the top of the stack. On top of the stack we have 3. we will put 3 in on the 0th position in the result, and now there is no 3 because we just popped it. And that we will see if the 3 now has its own left and right. Yes, it does. So we'll be popping the left first, then the other. So now we will just uh, do the same and pop it all. Like 6 will go first, and then there will be 7, and then all of this is done. Okay, we are done from the right side. So what are we going to do now? We have two. We will pop two out of the not two out of the stack yet, because we will be going to see if this two has its own left or right. Yes, it does. We will be popping it out of the stack, putting it here now, and we'll be putting 4 and 5 in the stack because it was 2's left and right. And like the same procedure, we will again pop it out of the stack, first 5 and then 4, and that's it. This is how we make our result. And if you check, we have the left values first, then their right, left, right parent. Okay, then right, left, uh, left, right parent, and then the root node. So this is it. Like, that's it.